Hello, and welcome to our overview of the scientific revolution, one of the most transformative periods in human history. In this video, we'll explore the ideas and thinkers that shaped modern science and shifted the way humans understand the world. There'll be kind of four parts to this video. So, first, what did people believe before the scientific revolution? Who are these main scientists? What advancements happened in medicine and anatomy? And then, what are some overall effects of the scientific revolution? Before we jump in, let's clarify some terms. What we now call science was referred to as natural philosophy in the 16th and 17th centuries. The term scientist isn't even created until the 1830s. And at the time, thinkers were grappling with traditions like scholasticism and Aristotelianism, which heavily relied on ancient authorities rather than observation. So, what exactly counts as the scientific revolution? Well, it's this sweeping intellectual movement beginning in the 16th century and unfolding across several generations. It wasn't isolated. It happened alongside other events like the Reformation and later the Enlightenment. And the first scientists were often priests and monks seeking to prove the existence of God through reason and observation. Now, before we can talk about the revolution itself, we need to look at what was, going on before this. What did people believe and how does this make a marked change from those beliefs? Now, before the scientific revolution, scientists are going to seek to understand how things happen, and the intent is to use science to prove that God exists. The earliest scientists are usually priests and monks, and these early scientists are usually astronomers. They're looking into the skies, trying to find meaning and order in the world. And a lot of the ideas that they're going to be trying to prove are based off of Aristotle and then Ptolemy. And so before the scientific revolution, the beliefs are really that the earth is the center and that the sun kind of goes around the earth. And you can see here Ptolemy's geocentric system, kind of what people believed at this time. Meanwhile, superstition and fear were very real forces in people's lives. Belief in magic was widespread, even among the educated population. And by the Renaissance, people genuinely believed things like witches flew, they consorted with the devil, they ate babies, and this fear, especially in regions experiencing religious upheaval, is going to fuel the early witch hunts. And a lot of people will be persecuted for witchcraft, especially women. There's actually lots of different tests that they would do to kind of examine if you were a witch, like if you had moles or birthmarks, those were signs, that the devil had, touched you in some way, or, they had these different trials they would do, like if you sunk or swim when they tied you and threw you in the water. And ultimately, I mean, they're just means to kind of rid, superstitious evil from their communities. And even those who dismissed bad magic often held on to the idea that there's good magic out there. So, for example, Queen Elizabeth I reportedly wore a magic ring to ward off the plague. And practices like astrology and alchemy were seen as forms of natural magic, which is a precursor to scientific investigation. So, why did things begin to change? Well, there's several key factors to think about for this. So, the first thing that happens is navigation challenges during overseas exploration prompted more precise observations of the world around them. We see medieval universities had preserved and taught classical works, and the Renaissance it revives humanism and that emphasis on those classic works and emphasizes math and logic. And then finally, the rise of patronage in the print culture allows ideas to circulate more kind of widely across Europe. And with the Protestant Reformation in full swing, we'll see that religion is no longer the only possible explanation for events. People start questioning things. They want logic over faith, they want verifiable proof that something's happening. And that's going to be a big change. Okay, now let's take a look at some of these early scientists. We're just going to do a brief, quick overview of what they're best known for. And these scientists are kind of broken down into three different sections. So we've got our astronomers, our people that practice the scientific method, and then we've got the synthesis, the people that are taking it and bringing it all together. And first up, we're going to start with our astronomers. So, first is Nicholas Copernicus, who's a Polish priest and astronomer, and he publishes this work called On the Revolutions of Heavenly Spheres in 1543. And he proposes this radical new idea that the Earth was not the center of the universe, it was just another planet orbiting the sun. And though he still uses that same idea of circular orbits, this was a pretty revolutionary break from traditional science during this time. Then came Tycho Brahe, an eccentric Danish noble who built his own observatory, and he charted the stars with remarkable precision and noticed comets and supernovas that challenged the idea of a perfect and unchanging sky. And his model was a hybrid of geocentrism and heliocentrism, trying to balance science and religion. He's trying to walk that fine line. And then after him comes Johannes Kepler, who was actually Brahe's student. He took things even further. He formulated what's called the three laws of planetary motion, which basically just proves that orbits are elliptical, not circular, and that planets are moving at various speeds. So, like the Earth is not moving at the same speed as Venus. And he lays the foundation for what's called celestial mechanics. And then we have the person who's probably the most famous scientist, of the astronomers, and that's Galileo Galilei. And he's also perhaps the most controversial. So, using a telescope, he discovers craters of the moon and the moon's orbiting Jupiter, evidence that basically everything is not revolving around the Earth. He has this concrete evidence. And he also studied motion and gravity. But when he publicly supports his heliocentrism theory, the church places him under house arrest because they think that he is actively defying the teachings of the church with his ideas. And he's forced to kind of recant and apologize for his views because the church is going to, kill him if he doesn't. And we'll find it's not just the Catholic Church that's really critical of Galileo. The Protestant churches also didn't like him questioning kind of this traditional Christian doctrine. And the only places that will kind of like pursue his train of thought are going to be in England and Holland, places where scientists had a lot more freedom to pursue and publish their work. And they create these hubs for innovation. Okay, so now we've gone through all of our kind of astronomer scientists, and let's look more about the scientific method, which is what's going to be created by men like Francis Bacon. So, Bacon is the champion of inductive reasoning. So, you start with an observation and then draw conclusions based on that. So, like, all the swans that I've ever seen are white, therefore, all swans must be white. Um, He's often credited with formalizing the scientific method, even though he struggles with the question how much evidence really is enough evidence, before you can make that general statement. And he spends a lot of his life kind of pondering that. And next up, we have Rene Descartes, who is a great mathematician, and he showed that any algebraic equation could be plotted on a graph. So you can thank him for all of the graphing that you do in your math classes. But he looks at the, deductive reasoning theory. He's the one that kind of coins that. And some example of that is like all men are mortal, Socrates is a man, therefore Socrates is mortal, which basically just means if the premises are true and the reasoning is sound, then the conclusion is guaranteed to be true as well. And he's also best known for the phrase cogito ergo sum. I think, therefore I am. And then finally, for this section, we have Sir Isaac Newton, who's probably the greatest scientist who ever lived, through the work that he produced and what's been produced because of him. And he was interested in math, physics, and astronomy. He wrote this piece called the Principia Mathematica in 1687, bringing together Galileo's discoveries about motion of the Earth and Kepler's discoveries of the heavens. And to do so, he had to develop calculus. So, I mean, he created calculus like pretty much all on his own. And of course, it's through Newton that we get ideas about inertia, motion, um, laws of gravity. All of those things come from him and his invention of calculus. All right, so this revolution doesn't just stop at astronomy. In medicine, breakthroughs included the first accurate anatomy books, the first microscope, and even the first stitches. The first scientist we'll look at here is Paracelsus, who's a Swiss physician who broke with tradition by using chemicals and minerals in medicine. And he's kind of known as the founder of pharmacology. He's credited with founding toxicology as well, and even noted links between mental and physical illness, making him a precursor to modern psychology. Then we've got Andrew Vesalius, who is most known for his work with the human body. So he's referred to as the founder of modern human anatomy. He creates an accurate skeleton system, muscular system, and his work with the vascular and circulatory systems was his greatest contribution to modern medicine. And then to wrap up this area, we have William Harvey, who demonstrates how the heart works. And so he explains how the heart functions like a pump in his book on the motion of the heart and blood. And it's going to change the way that scientists understand biology. Now that we've looked at most of the key players in the scientific revolution and what their ideas were, let's talk about the effects that they're going to have. Here are some of the big ones. It's going to widen the intellectual gap between the elites and the masses. There's going to be huge differences in education levels between those who are studying all of these new things and those that have no access to education. We are going to see improved navigation and artillery that are going to reshape global politics. We'll see life expectancy is going to improve and infant mortality declines. And crucially, science becomes a new lens for understanding reality independent from religion. And we've reached the end of our time for today. Thanks for joining us on this journey through the scientific revolution.